Hey guys, this is Yogesh Sharma. Welcome to my session. Today's my topic is intelligent serverless and scalable real-time data pipeline using Kinesis, Fargate, and CloudFormation. Before moving ahead, let me introduce myself. I'm Yogesh Sharma, working as a cloud data architect in Tata Consultancy Service. I'm currently having 10 plus years of experience, and since last 5 years, I'm working in cloud and data field. I am currently in the AWS APN ambassador and AWS community builder. I'm also a technical speaker and blogger, and you can connect me over LinkedIn with the mentioned link. So let's get started with the agenda. Today we will talk about the serverless construct and how serverless will play a role in designing the real-time data pipeline using Kinesis. And after that, I'll showcase you like how we can create the both consumer and producer application on the Fargate, that is a serverless construct of a container in AWS. And then towards the end, I'll quickly showcase one demo. Okay, so to start with, what is serverless? So serverless basically allows us to build and run application without any servers. And that means there is the like we as a developer, we don't need to worry about any provisioning or management of server. So the serverless services require no server management. This means we don't need to worry about to install and manage any kind of software. Application made through AWS serverless construct can also do scale automatically, and this is done by manipulating the units of consumption like memory, CPU, and also toggling any other server settings. The next benefits for the serverless is the pay for value. So whatever you are consuming, whatever you are using, you are going to pay accordingly. And the last would be the benefit to the serverless application made through AWS is that there is no idle capacity. There is no charge when the code is not running. And also it is the AWS serverless construct have built-in tolerance and availability. So if we look at the AWS service portfolio, we AWS provides like a lot of different services with respect to the each and which is the different domains. Like if we see on the left hand side of our diagram, we can see the traditional way of doing things. Like for example, for the compute, we were having virtual machines. For database, we used to have like MySQL on premises. For storage also, like we used to have like the whole storage infra on premises and so on. But as we gradually move towards the right part of the diagram, we can see there are various serverless constructs that almost all the cloud vendor provides, but we focus on the AWS in this session. So like for the compute, we do have AWS Lambda, we do have Fargate, that is a serverless container construct. If you talk about the databases, we have Aurora serverless, we have DynamoDB, that is a key value database, that is also a serverless. We don't need to manage any server if we are going to use the Dynamo or Aurora serverless. For storage, we have an excellent example of Amazon S3, that is a block level storage, but we don't need to manage anything. We just need to dump our data, and after that we can define the lifecycle configuration, we can define the replication configuration, encryption, and so on. And the same goes with the messaging and analytics. Like we do have Athena, we do have Elastic services, we can use SNS and SQS for notification and queuing services. Moving on. So what is the serverless? Why serverless provides a great agility? Because serverless handles all the capability such as storage, database, messaging for the developer. And we as a developer or we as a programmer, we just need to focus on the business application that we want to write and we want to serve our customer. We don't need to worry about all the heavy lifting. All the heavy lifting will be done by the AWS. Now moving on to the data streaming. So for streaming data, there are a few characteristics for the streaming data. Like data is continuously generated by different sources, such as data should be processed incrementally using stream processing technique without having access to all of the data. It should be continuous, low latency. And there are various use cases for the streaming data, because streaming data is the data that is generated continuously by thousands of data sources, which typically sends the data record simultaneously and in small sizes. Like for example, we can think of application logs. Like we suppose we have a lot of EC2 instance. We do have a lot of virtual machines, and it is generating the data. But now we need to collect all the logs, like suppose the Apache server log or the general Linux var log messages. So we can create a stream using the Kinesis. We can export all the logs maybe to the CloudWatch or maybe to the S3, or maybe we can ingest that all the logs into the Elastic services or Splunk. Similarly, we can think of an example of IoT sensor. If it is generating the continuously stream of data, then we can use Kinesis, and then we can further store the data somewhere else, or maybe we can perform the analytics on the fly. But there are few challenges when we deal with the streaming data. Like it is difficult to set up how we are going to set up the streaming solution. Scalability could be an issue. It is expensive to maintain because we don't know how much data we are going to have in near future. I mean, we need to define beforehand, like what could be the rate of data, whether like you suppose it would be like 5,000 requests per second, or it is just like 10,000 requests per second. Accordingly, we will create our solution and we will define the scalability. And obviously, if we are going to manage on our own, the availability, durability would be an issue. We need to make sure like our streaming solution should be available all the time, and it should be durable, and it should be scalable. But now if we look at the AWS Kinesis, it basically solves all these challenges. It makes easy to collect, process, and analyze real-time streaming data so we can get timely insights and react quickly to the new information that is coming. It is fully managed, real-time, and scalable. So when we talk about the AWS Kinesis, so there are few components, or I would say sub-components within the AWS Kinesis. Like we can choose to create a Kinesis data stream, Kinesis data firehose, Kinesis data analytics. So when we talk about like we just need to create a real-time data pipeline, we can use the Kinesis data stream. But suppose if we need to, if we are having some kind of use case where we are getting the real-time data, but we need to store it somewhere, like because we are working on AWS, so like we need to store that data on S3, or we need to ingest that data onto the Redshift, or we need to ingest the data onto the Elastic service. Then we can use the Kinesis data firehose because it provides inbuilt connector from the producer side and also to the consumer side. So consumer would be the S3 location or the Redshift or the Elasticsearch. Similarly, Kinesis data analytics. If we want to perform any kind of analytics on the fly, then we can use Kinesis data analytics. A typical real-time data streaming using the Kinesis works like, okay, we do have source. Source could be anything: mobile device, metering, clickstream. And after that, if as like the source is generating the data, after that we need to ingest the data. So for that we can use different construct that AWS provide. Either we can write our solution using any of the AWS SDK that is available in Python, Java, Node.js, or we can use the AWS Amazon Kinesis agent. That is very handy if we have a use case like we need to export all the logs to the CloudWatch or to the Elasticsearch from one of the EC2 instance or from one of the virtual machine. But there is a good, I mean, I would say the better solution would be to use the Kinesis producer library because it provides various inbuilt mechanism. Like it basically provides you the checkpointing function, like if something breaks in between, like if your application, if your source is generating data and something breaks in between, then it will store that checkpoint so that at the next run it will start from that particular point. Then with respect to the storage, or I would say streaming solution, we are going to use Kinesis data stream. Now the next would be the streaming processing. how we are processing the data, how we are doing the transformation, or if we want to perform any analytics on the fly, how we can use that. So we can, as I mentioned earlier, we can use the Amazon Kinesis data analytics if we want to perform any kind of analytics on the fly. Uh, but there is an alternative available. We can create a consumer, like in our demo. I'll showcase you in a while. Like we have created one consumer, and in the consumer, I'm using the I have created the consumer using the Amazon Kinesis consumer library. It is also a pretty good library provided by AWS, and we can create our consumer. We can write that code in either Python or in Java using the Amazon KCL library, and it provides various inbuilt functionality like the DynamoDB connectivity to store the checkpoints. Also, there is an enhanced fan out mechanism where we get the 2 MB throughput per consumer that can also be achieved using the Amazon KCL library. The last would be another option would be the Amazon Kinesis data firehouse if you want to send the real-time data to the specific storage location. As of now, only 4 locations are available, like S3, Redshift, Elasticsearch, and Splunk. Now we'll talk about the Kinesis chart. So Kinesis data stream is a set of shards, and each shard has a set of sequence of data records. So each data record has a sequence number that is assigned by the Kinesis data stream that will make sure your stream of data is unique. And shard is uniquely identified sequence of data records in a stream. A stream is composed of one or more shards. So it's like a partition. At the time of creation of Kinesis, we need to define how many number of shards we want. Though we can scale this later also as per our requirement, but the best practice would be if we can visualize or if we can determine how much amount of data we are going to get in this particular real-time data solution, so that we can define the shards accordingly. The data retention is 24 hours by default, but we can change it up to the 7 days. And as you know, because Kinesis is not like an SQS where we can delete the data. It's not like that. Once the data has been inserted, we can just consume it, and as per the data retention, it will automatically get deleted. We can't delete the data from the Amazon Kinesis. Now, how we can write the producing consumer as a serverless containers. So first, quickly talk about why we are thinking about containers. Why not we write the KP? Why not we write the producer and consumer on EC2 or virtual machine? I mean, we can write it, but there are a few benefits of container that we might be aware of. But let me quickly cover those. So container basically provides the isolation of the application from host system and from each other also. And definitely the resource utilization is another benefit of the container. If we can like I'll showcase that in my demo also. Like in the Fargate, we can choose, okay, what is the memory configuration that we are looking, what is the CPU configuration that we are looking. And it's not comparable to the virtual machine, because in virtual machine, suppose we are selecting a specific instance type, but we might be using, or that virtual machine might be using some other applications that are running. And it is like, if we are going to choose the virtual machine, it is like going to run on 24/7, right? So in terms of cost also, the containers can be beneficial. Also, the biggest benefit would be the portability. So with one of my client, that we implemented the real-time data streaming solution using the Fargate, they were running that application on containers on premise, but because due to the scalability and durability issue, they want to move on to the cloud. So the easiest would be, because they have all the codes and they have all the settings how we can create the container. So the easiest option or the fastest option would be just to migrate, or just to I would say re-architect that application onto the cloud and just use the Fargate container, because it's like serverless container service. We don't need to manage anything. We just need to uh, create our container, store it into the Elastic Container Repository, and then just launch the container with the right CPU and memory configuration, and we are good to go. So AWS also provides the container services that they call as ECS, Elastic Container Services. It is highly scalable, fast container management service that make it easy to run, stop, and manage containers on cluster. There are two options that we can choose when we are creating container, either ECS, that is Elastic Container Service, or EKS, that is Elastic Kubernetes Service. And being in both of the options, the launch type can be EC2 or can be Fargate. So EC2 would be like, okay, we are going to launch one EC2, and in that EC2, we will launch our containers. But when we talk about the Fargate, that is the serverless construct. So we don't need to manage the EC2. We just need to define, okay, this is my memory, this is my CPU configuration, this is my container image. Order scaling properties, like we want this container to be scaled in or scaled out depending on the CPU utilization or depending on the incoming data traffic also. Yeah, so Fargate, as I was explaining, is like we don't need to manage any cluster or any infrastructure. Everything is handled at the container level, not at the virtual machine or EC2 level. And it scales seamlessly on the demand. So AWS Fargate is serverless compute engine for containers that works with ECS and EKS both, and makes it easy for us as a developer to build our application, so that we don't need to worry about managing the EC2. We just need to focus on the business logic, and we are ready to go. The main construct how we can design the Fargate application is the task definition. So first we need to register the task definition, where we will define the application container image. Container image could be the path of Elastic Container Repository, where we are storing our container images, or it could be part of the Docker Hub. And after that, we need to provide the CPU and memory requirements. So now, once we registered our task definition, now we need to create the ECS cluster, and we need to run this task. We can run this task as a like separate standalone task, or we can choose to create a service, and we can attach this task definition to the service, so that all the tasks will run inside the service, and service will be inside the ECS cluster. Why AWS has introduced service is like, because the service would be act like a controller. It can maintain and run multiple copies of the task, and the service can be integrated and talk to the Elastic Load Balancer. And then it would be the responsibility of service to remove the unhealthy container, or to add the new container. So we can define the auto scaling policy to the service, and accordingly it will launch or delete the containers for us. So yeah, first we need to register task definition, create cluster, create service, and then run task inside the service. Now lastly, how we can automate the whole process using the CloudFormation. Because as you know, CloudFormation is infrastructure as code. We need to write the whole CloudFormation stack in either the YAML or in the JSON format. And then when we launch it using the AWS CloudFormation console or using the AWS CLI, it reads the whole CloudFormation template, and AWS CloudFormation will provision all those resources which we have written in our CloudFormation stack. Like in our example, we are going to need the Kinesis, ECR, S3 bucket, dashboard, the ECS cluster, task, ELV, and so forth. Okay, so let me showcase you the demo. But before going that, this would be the architecture that I'm going to build in my demo. So we would be having two separate container service, two separate services in an ECS container. One would be the producer, another one would be the consumer. So in both the service produce task and consumer task going to run, and both are under the auto scaling group with respect to the CPU utilization properties. And with producer, I have attached the application load balancer so that we will generate the data to the application load balancer. And application load balancer will transfer that data to the producer task, and then producer will put the data into the Kinesis data streams, and and then the consumer are going to consume the data from the Kinesis. Or we can also use the Kinesis data files to send the data onto the S3 buckets. Okay, so let's get started with the demo. Okay, so because keeping the session timeline in check, I have already launched two CloudFormation stack. One is going to create the Kinesis and ECR images, and second one is going to create the ECS Fargate pipeline, basically the ECS consumer producer task and related CloudWatch components. So if we quickly look at the CloudFormation construct, mm, yeah, for the ECR images, that is the first CloudFormation stack. So here we can see like we are first creating a Kinesis data stream with the shard count of 1. After that, I'm creating the Kinesis delivery stream because I want to send the data into the one of the S3 bucket. Now, yeah, I'm creating one S3 bucket also, so that with Kinesis data first firehose, this S3 bucket will be considered as a destination. Now I'm creating a bunch of IAM role and policy because I want to assign the respective permission to both Kinesis, to both my code build project and also to my ECS cluster. Now, let me go towards the end. This is the code build policy. So I'm creating a AWS code build project. In this particular project, I'm creating and pushing. So I have defined my build spec. So in that, I am basically creating and pushing my Docker images. So if you see quickly the command, so I am creating the Docker build image. First, I am basically cloning my GitHub repo. So this is my GitHub repo for this demo. So I'm cloning that repo, and then I'm creating the Docker images, tagging it with the respective tag. And at the end, I'm pushing it onto my AWS Docker Elastic Container Repository. Okay, so if you see this is the first CloudFormation template. The output would be Kinesis stream, Kinesis files, producer repository, and code build Docker image. Now, if I'll show you the this is the data stream that has been created using the CloudFormation. It is only having the shard count 1 because of this demo. This is the data delivery stream, and I have attached one destination source that is an S3 bucket with this delivery stream that is basically essentially a fire hose only. Now, just a sec. Yeah, this was the S3 destination bucket for that delivery or Kinesis data fire hose. Now this is the code build project I was talking about. So I have already executed it. So and it is basically creating all the Docker image for both producer and consumer and pushing it onto my Docker ECR repository. So if you see this is the Elastic Container Repository. If you see this inside it in the producer, I have pushed one. I have pushed like 3 images, but yeah, I have tagged the latest one with the latest tag, and this is the image related with the producer. Similarly, I have the image for the consumer too. Now, let's quickly traverse through the second cloud formation. In this particular cloud formation template, I'm creating the Elastic Container Services and all the tasks. So, yep. Just a sec. Yeah. So this is the task definition. Here I am providing the CPU and memory requirements and also the image. So image would be the producer and the consumer image. Like which particular container image I want to run and what would be the CPU and memory requirements for that. So I have already executed that CloudFormation template also, and let me quickly show you the ECS. So yeah, this is my ECS cluster. If we go inside it, we can see there are two services running: consumer service and producer service. So if I go inside the producer service, I can see it has been associated with one of the EEL ALB because we want to push the data towards the ALB, and then ALB will send the data to the respective producer container task. Now, if I click onto the container or the task, so this is basically a running definition, I would say the running construct of our task that we defined. So this is a container, running container. You can say, yeah, container runtime, it's running the memory and CPU requirements. Now, what I'm going to do is I am going to send, uh, I'm going to generate some amount of data. So what I have done, I have created a file. So if you see, it's just like it is going to send, this is going to generate and send this data onto my ALB. So I am going to run this, and I'm providing it as a first argument, and on the only argument is my ALB name. We can get the ALB name from the CloudFormation console. So this is the HTTP ALB endpoint. So I'm using that, and now I am generating that data. Meanwhile, I am also what I am going to do. I am also going to generate a good amount of data using the locust. So locust is just a tool that we can use to as a performance testing tool or as a load testing tool, just like we have artillery and various other tools in the market. So that I'm going to generate the humongous amount of data and will send that data onto the application load balancer. So let me open it. So yeah, you can see this is my ALB STDB endpoint. Now I am going to put number of users, and the spawn rate would also be, maybe let me increase it. Now if I'll quickly check the, yeah, so this is the dashboard that has also been created using the cloud formation. So if I'll just quickly check, it will be updated in a while because I've just started to push the messages, but I can see, like, okay, the current count, because I triggered and I sent few requests, so you can see the number of messages by 926. Now I want to see the whether the data is getting generated or it is coming into the CloudWatch, because all the container tasks that we are running, those are associated with the CloudWatch also, because the serverless Fargate is a managed services, so it is associated with the CloudWatch log also. So if I'll quickly showcase you, yeah, this is the logs. So similarly, I can see this in the into the CloudWatch log inside, and I'm going to run my query. So now I can see few data that has been generated, and this data is being generated using our locus tool. That is why you can see this is our load test request. So I'm pushing this data, like multiple records of this data into my Kinesis data stream, and I can see like this data is getting refracted and being consumed using my ALB, and I can see that this data is coming into my CloudWatch logs. Similarly, similarly there is a log group for consumer also. I want to show you one more thing. Yep. So now we can see, because I just started. Yeah, so you can see in the locus the number of requests it has fired is like 78,000, and if I quickly check in the dashboard, I can see uh, the user records is getting generated. It's like around 3,000 records, and it will be updated in a while. Let me quickly check the ECS configuration. Sorry. Uh, Producer service. Currently, this producer service task is in steady state. But let me check the order scaling component. It's like minimum task is one. So if I just click on update, next tab, next tab, and let me check the Kinesis producer scaling policy. Okay, so the target value I put it is like 25% of CPU utilization. Right, so CPU utilization, and scale out period and scale in period is like 10 seconds. So it is basically, it is what this means is like when the producer task CPU utilization is above 25% for at least 3 data points, then it will trigger a new task. So let me cancel it. So yeah, if you see now the desired task has been changed to 3. So if I click on to the producer service, desired task has been changed to 3. As of now, it was running only 1, but pending count is 2. So it must be trying to create 2 more tasks. Yes. So if we see here, earlier it was in steady state. Now set desired count to 2, and it has already started 2 tasks. It'll take a while to launch these tasks. Let me do a refresh. Yeah, so now running task is 3. It's pretty quick. It's not like, because container lightweight process, not like the actual VM or EC2 instance. Now, if I'll quickly check the, just give me a second, quickly check the dashboard. Let me refresh the dashboard. Yeah, now look at the user records. User records are almost like 30,000 because of the locust tool, and it will be updated. I think in because it's the CloudWatch dashboard, so I think by default it is updating in 5 minutes, but it will be updated with number of tasks as a three because we have already seen our ECS container are currently running with three tasks, three producer tasks. So yeah, hmm, yeah. Let me move on. Yeah, so that was the main demo. Like we launched the producer task and consumer task in the ECS Fargate construct, and we launched we were test one application load balancer to our producer task, and all both of these producer tasks are under an auto scaling group, and we have just seen as we increase the data load, the Amazon ECS Fargate service launches few other tasks with respect to the CPU utilization scaling policy criteria. So yep, yeah. So that is all, folks. So this was my demo. I hope you have enjoyed this session, and I'm able to communicate. I'm able to. You enjoyed the session and both the demo. Thank you. Thank you so much. Have a great day.